All right, boys and girls, today we're going to be talking about more log functions and exponential functions. Today is kind of the first application day. We're going to be talking about money, essentially. We're going to be taking this formula right here and comparing it with the formula that we already talked about with natural log. So as we look at this top equation right here, the n stands for, or could stand for multiple different things. So if it says compounded annually, obviously one time annually a year. Quarterly would be 4 times a year. Monthly would be once a month, so 12 times a year. Weekly would be 52 weeks, 52 times a year. Bi-weekly would be twice a week, so that'd be 104 times. And then daily, banks usually are only open 360 days as opposed to 365. If the problem says compounded continuously, that's when we're using that PERT formula that we talked about with natural log. You will need a calculator for this, so if you don't have one, pause it. And if so, let's go ahead and get started. Number one has us comparing two different bank accounts. So it says he starts with 2,500, so that's the principal. So we don't know what we're finishing with, so that's going to be A for both of them. The starting amount of principal is $2,500 for both of them. Since B says continuous, we're going to be using the PERT formula, so 2,500 times E to the RT. Now the R is our interest rate, it's in percentage, so we're going to do it in decimal, so 0.095, and then times the amount of years would be 8 years. For our quarterly equation, that's the new one, we're going to do 1 plus, and then my interest rate, still 0.095, and then over the amount of time it's being compounded. This is quarterly, so it would mean 4. And then to the 4, it's the same number there, and then for 8 years. So now this is just an exercise in plugging it into the calculator and going. Now what I would caution you to do is go right to left when you're putting this in the calculator. If you go left to right, you may make some errors along the way. So take 4 times 8, multiply that times 32. Then take 0.095, divide that by 4. Add that to 1, then multiply, or sorry, then take that to the 32nd power, then multiply that times 2,500. And then you can do the same thing for continuous. Take 8, multiply it times 0.095, then take E, that's the second natural log button, to all of that, and then multiply by 2,500. See if I have the answers up here. There we go. So you should get $5,298.41, and then $5,345.69. So the difference is not much there when we're talking about quarterly versus continuously, when we're dealing with the same amount of money and same interest rate. All right. I have number 2 up. I did this during class today, and it's a lot of work. So go ahead and copy all that down. So I'll give you a chance to copy it and then I'll pause it. It's just a really long problem that is asking you to compare two things. So instead of working through it all, just go ahead and copy it. Here's your chance to pause it. Right, here we go.
Is Jacob passing the test?
Okay, so let's go ahead and take some time to go over this. Alright, so we're comparing two different bank accounts that we want to get to 20,000. So that's why they both equal 20,000. We're both starting off at 1,000. Now for the continuous one, just like number 1, we're going to have E to the 0.062. That's our interest rate, 6.2%, and then times T. For the monthly one, since our N, 12, is our amount that we're compounding per year, so that's why 12 in the denominator and 12 there, we still don't know the time for either of them. So now we've got to work backwards. We're solving for T. So this is where things get a little complicated. We're first going to divide, obviously, by 1,000. Divide by 1,000, I get 20 for both of them. From there, if you recall, when I have an exponent, an unknown exponent at that, I have to take the log, or if I'm using E, the natural log of both sides. So when I do that, I am able to move that exponent down. I have arrows drawn for that. So next, I'm going to divide by anything that is not T. I'm trying to get T all alone. Over here, I have natural log of E canceling out because that's what happens when you take the natural log of E. So we do that. We divide by 12 log of blah, 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 blah. I divide by 0.062. I put this in the calculator. Be careful. If you're doing log 20, I would be sure you close your parentheses there, then divide by all that junk. When you do that, you can see there's really not much of a difference there as far as the amount of time it would take for $1,000 to reach 20,000. Okay? We're not going to stop there. We're going to go through most of these. But that way, if you can do this problem, you can probably do any of them. Okay? All right, let's continue on here. Number 3, pretty easy. We just got to work backwards. Let's see here. Sorry, I didn't make it difficult. All right, so we're starting off with $20. I don't know how much it's going to end up with. It says 6% interest compounded annually, so that tells me I'm going to use the 1 plus formula. My interest rate 0.06 divided by number of times compounded, so 1 time a year, and then 1 times, sorry, to the 1 times 50. So I got 20, 0.06 divided by 1 is just 0.06, so 1.06 to the 50th power. So that's all I'm doing in the calculator is taking 1.06 out of the 50th power and then times 20. I think you get around $300. I'm going to double check here. Yeah, you get $368.40 as my answer for number 3. Alrighty, let's move on. Number 4, anytime it's asking for time, we got to work backwards. So for this one, if it says estimate, find, or predict, or whatever the time, that's meaning we're going to have to be taking the log of both sides. It's compounded annually, $2,500 to double, so that would mean we start with $5,000 on the left-hand side. My initial amount, my principal is $2,500. I got 1 plus my interest rate, 0.08, divided by compounded annually. Annually just means 1. And then 1 t, I don't know time. So if I'm isolating t, if I'm trying to get t by itself, I'm going to first divide by 2,500. I get 2 equals 1.08 to the t. 1 times t is just t. Now from here, we're supposed to take a log of both sides because I can't get that exponent down. So I have log of 2 equals t, because if I take log of both sides, I can move that t in front. The last thing I do is I divide both sides by log of 1.08. So t is going to be log 2 divided by log of 1.08. So in your calculator, what this looks like, not that. Yeah, so you get about 9 years, and be sure you close your parentheses there, or you're going to end up with a different answer. So our time is around 9 years. Number 5 is going to work the exact same way. It wants to know how long something takes to get there. So if $1,000 is trying to get to 2,000, I'm working backwards. 2,000 equals 1,000. Annual percentage rate, so that would be 12%. So 1 plus 0.12 over, it says compounded monthly, so 12, and then 12t up there. So same process, divide by 1,000, do this math, take the log of both sides, yada yada yada. So when we do that, we get about 5.8 years. Gotta be sure you take the log of both sides. Alright? Last thing I had the kids do is do number 6 and 8 by themselves. So we're not going to do number 7. It works like number 2. You're comparing. No need to do that. Where I did one like that. So try number 6 and 8. And I'll give the answers here in a second. Here's a chance to pause. All right, number 6. You're just plugging and chugging. You're taking 7750 times e to the 0.04 times 5. Plug it all in the calculator. Remember, go right to left as opposed to left to right. Number 8, we're working backwards. So if you want to get to 5,000 starting with 20,000, you have compounded continuously. So I don't need the 1 plus, I need the R. So I have times E to the 0.15 T. So you divide by 2,000, take the natural log of both sides. That's how you get 6.109. All right? Good luck, guys. Catch y'all later.
Peace out.